Hi class, welcome to exercise 4E, applications in 3 dimensions. There's only one example in this class, and that is example 9, applying trigonometry in 3D. And your pre-learning for this example is questions 1 and 2 in the new book and question 3 in the old book. Our example is basically just the title of the lesson, so let's just get on with it, and I'll see you in the introduction. We've already looked into real-world applications for trigonometry, but now we're going to take the third dimension into consideration. So let's recall what we did with 3D Pythagoras, and for that I'm going to need to draw this box and mark in these points A, B, C and D. Now if we're going to find the distance of B to D, we constructed the triangle BCD, but also constructed the other triangle ABC. And in this case, it was almost like ABC was secondary evidence to find BCD. Now we can use secondary evidence for trigonometry in much the same way. So for example, if I draw two right-angled triangles, and you can see I've marked in this height Z, so let's mark in these angles alpha and beta, and these side lengths X, S, T and Y. So we've got two right-angled triangles here, and two measurements from one allow me to figure out all of it, which includes Z. And because we now know Z, we'd only need one measurement from the other triangle to be able to figure out everything about that. And you should know by now that once we know it's a right angle, then Pythagoras and trigonometry only require two measurements to allow us to figure out the whole thing. Okay, I think my picture was pretty clumsy, limited by my lack of artistic ability. So let's pop over to GeoGebra and we can have a much better look at this. Once again, you can follow along with this link, which is on the OneNote. I think you can agree that GeoGebra is much clearer than my drawing. So let's move around so we can see the 3D nature of this scenario. Now we can see there's two triangles sticking up and two of them lying on the floor. I've marked in the right angles for all of them, so we're clear what sort of triangles we have here. Notice that despite the scene being 3D, the triangles are 2D. These triangles are supposed to represent some part of a pyramid. So we can look for triangles in shapes like this, just like we did in that box for the 3D Pythagoras. Now if we focus in on these triangles, we can see that their interconnectivity shows us that figuring out measurements of one of these will give us the measurement of the other. So for example, if I know this angle and this length, then I could figure out the height that's in the middle of the pyramid. That means that I only need to know one measurement of the other triangle, and then I could use either trigonometry or Pythagoras to figure out all of its other measurements. I'm actually going to go straight from GeoGebra into the next section because that is the end of the introduction, and I'll see you there. Okay, let's reiterate the important steps for applying trigonometry in 3D. First, you need to recognize where the 2D right angle triangles are in the 3D space. Then you can use trig functions, normal or inverse, or Pythagoras to figure out other measurements of this triangle. And then you can recognize where the other right angle triangle shares measurements and attach those measurements to figuring out other parts of that one. So let's try and put all these skills together with example 9, where we have a vertical mast that is supported by two cables reaching from the points AB. The cable from point A is 36 meters long and is at an angle of 48 degrees to the horizontal. And going along the horizontal, B is 24 meters from the base of the mast. In part A, we're asked to find the height of this mast. So let's just redraw the triangle that the cable from A and H make with the horizontal. So clearly H is opposite and 36 is the hypotenuse. So opposite and hypotenuse means we're going to use sine, and we have 48 degrees here, so sine of 48 is going to equal H over 36. In other words, H is equal to 36 times the sine of 48. And if I put this into the calculator, that means H is equal to 26.75, rounding off to 2 decimal places. So we've got some information from our first triangle. Let's move on to part B, where we're going to do some work with the second triangle. So in part B, they ask us to find the angle that the chord from B makes with the horizontal. So let's have a look at that diagram again, and I'm going to mark in this angle theta. So you can see now we've got this height H, the horizontal is 24, and we're looking for that angle theta. Alright, we better move back down and draw this diagram again. So H is the opposite and 24 is the adjacent. So therefore tan of theta is going to equal H over 24. Now I could sub in the value 26.75 for h, but we're going to do another function here, so it's much more accurate to use 36 times sine of 48. So to find the angle we need to get inverse tan, so theta will equal inverse tan of everything on the right there. And I just want to make a note here for anybody who reads it that we've made an obvious choice for better accuracy. Well, this is pretty complicated and it's definitely a calculator problem. And just notice that I'm using a tan for inverse tan in OneNote now. So we're not going to do any more steps with this question, and I'm going to round off here. So theta is equal to 48.11. So that's one simple example. There are plenty of these in the exercise, and just get stuck into them. And when you start to hit hurdles, that's when it's time to ask me for help. All right, I'll see you in the summary. All right, this is the last lesson for our block, and all other trigonometry we're going to do this year will be very different. So make sure you do plenty of questions in this exercise, so that way you're going to learn how to apply trig and Pythag to 3D as well as the 2D we've already learned. But also you're going to see your strengths and weaknesses with trig, and it's a good time to catch that. All right, so to be successful in this lesson, you will be able to visualize right angle triangles in 3D objects, and be able to draw and label these right angle triangles that are formed in the 3D objects. And finally, know how to apply the trigonometric ratios to find an unknown and relate this to the original object. Alright, so there it all is. Have a great day, enjoy the rest of the lesson, and I'll see you in the next video or in class. Bye.